All right, so we're going to look at shifting ellipses and how that works. So I do have my formula sheet that has normal ellipses on it as well as the shifted part on the bottom. So our typical ellipse equation, we have two of them depending on if it's a horizontal or a vertical ellipse. If we have a horizontal ellipse, we have x squared over a squared plus y squared over b squared equals 1. And then a is always bigger than b, and then they're both bigger than 0. For a vertical ellipse, we have x squared over b squared plus y squared over a squared equals 1. So this is how we can tell if it's horizontal or vertical. Since a squared is always going to be larger than our b squared, since the a squared is under x squared, that allows us to recognize that our ellipse is longer on our x-axis, so it's horizontal. For this one, our larger denominator is under our y squared, so it's going to be longer on the y-axis, which is vertical. When we have a shifted equation for our ellipses, we have x minus h in parentheses squared over a squared, and then y minus k So the only thing that is different is now we have the h and a k, which is very similar to our parabola. Our center is going to be at h and k. Before, our center was at 0, 0, which meant if this was 0, x minus 0 is just x, and that's being squared. And if this was 0, y minus 0 would just be y, which is squared. But now if h and k are numbers, our center is going to be somewhere else. So then for this one, we have h and k again. H is always by your x and k is always by your y. So we're going to start with example 1. It asks us to sketch the graph of that equation, and we have to identify some characteristics first. So the first thing I notice is that my larger denominator here is 9, and since that is underneath my y squared, I know that it is going to be vertical. So this is a vertical ellipse. How it has been shifted, we are looking at this plus 1 here and this minus 2. And if we think back to when we did shifted parabolas, it is kind of the opposite of what it looks. So this 1 is actually telling us it's going left 1. And then this 2 is going up 2. So up 2. We can find our A and our B, and then using our formula sheet, we can find C. So A and B are pretty easy because I know, I'm going to use a different color here. This is A squared, and this is B squared, my two denominators. So if A squared is 9, I know that A is the square root of 9, which is 3. So A is 3. If b squared is 4, I take the square root of both, so that means b equals 2. To find my c, I want to use the formula that is on my formula sheet, so I'm going to show that. Let me scoot this up a little bit. So this one right here, c squared equals a squared minus b squared. So that's what I'm going to use to find my c. So I'm going to plug in what I know. Well, I know a squared was 9. So I have 9 minus 4, because the 4 is my b squared. 9 minus 4 is 5. So that means my c, I'm going to go this way, c is the square root of 5. And that ends up being a decimal. So right now I'm going to leave it like that, and then I'll switch it to a decimal later on if I need it. I'm going to actually do all of my original things first, and then I'll go back and do the shifted version. So I'm going to scoot this up a little bit so we can see it. Our original center was 0, 0. That's done for us. So I'm going to move on to our original vertices. So looking at my formula sheet, I'm going to scoot this over. For an ellipse that is vertical, my vertices are at 0, comma, plus and minus a. So before we wrote them as plus or minus, now I do want to write them as two separate vertices. So I'm going to do 0, comma, positive a, which my a was 3, and then 0, comma, negative 3. And this is because when we shift it, we're going to have to add something to each point, and so it's easier if we write them separately. My foci, excuse me, my foci is based on my C value, and I still write it as 0, comma, whatever my C value is, and I want the plus or minus, again, written separately. That's why we have two blanks here. So I'm going to do a positive square root of 5, because that was my C, and then 0, comma, negative square root of 5. Make that a little bit darker. And then my minor axis length, if we forget what that is, I'm just going to look at my formula sheet again. So it says it over here. So my minor axis is horizontal with a length of 2b, because I'm looking at a vertical ellipse. So 2b, which would be 2 times 2, which is 4. So my minor axis has a length of 4. So I'm going to switch pen colors so I can do all of the new stuff in red. So my new center is -1, comma, positive 2. So -1, comma, positive 2. My h and my k from my equation. So if you want to make a note to yourself, it would be h, comma, k, whatever that is. So for our vertices, what we're going to do is we're going to take our original vertices and we're going to add this point to it. So I add my x's, get my new x value. I add my y's, get my new y value. So 0 plus -1 is -1. And then positive 3 plus positive 2 is a positive 5. So that's one of my new vertices in my shifted ellipse. I do the same thing. 0 plus -1 is -1. -3 plus 2 is -1. For my foci, same thing. I'm going to take each point and I'm going to add my new center to it. Now, since I have the square root of 5, this is where I do want the decimal version, or I'm going to do it in my calculator. So 0 plus -1 is -1, and then square root of 5 plus 2. So I just did that in my calculator, 4.2-ish. Say 4.24. And then I'm going to add this point to this again. So 0 plus -1 is -1. And then this time it's a negative square root of 5 plus 2. And that gives me -0.24. So we found our information, and so what we're doing right now is we're combining basically what we know. So we've worked on finding the original stuff for 3B, that skill for ellipses, and then when we shifted parabolas, we did the same thing where we added our new vertex onto it to get the new stuff. Same concept when we do ellipses. So at the bottom, I'm going to go ahead and sketch what it'll look like with my characteristics. So I'm going to scoot it up enough so we can see the graph and the characteristics. So I'm going to make my coordinate plane. And let's see, I'm going to go 2, 3, I'm going to go 5. In either direction. So my new center is at -1, 2, which would be here. I'm going to label it with a C. My new vertices are at -1, 5. So this is one of them. So I'm going to do V sub 1. And then -1, -1 is going to be my other vertices, so V sub 2. My foci, I don't have that many colors of pens. Let's see if the green one works. So I have -1, 4.24, which would be like here-ish. So this is one of my foci, and then -1, -0.24, which is here. So foci number 2. And then I need an oval, because that's what an ellipse is, but I don't know how wide it is, which is why we had to find the minor axis length. So it has a total length of 4, which means I want to go 2 in either direction from my center, which is my B. So starting at my center, I'm going to go over 2 and I'm going to put a point. And then starting at my center again, I go 2 in the opposite direction to get a total length of 4. And now I can connect my dots to form my ellipse. So I go up to one of my vertices, and then, oh gosh, it's a little wonky, but it's okay. And that's our ellipse. I'm just going to label this real quick. So this is our minor axis. So that's how we knew how wide to make our ellipse. I'm also going to go through example 2, but I'm going to go a little bit quicker. So feel free to pause the video if you want to try it on your own and then see if you are correct. So for this one, I notice larger denominators under my x, so I know it's horizontal. It has been shifted right 3 units, and it hasn't been shifted up or down because nothing is being added or subtracted to the y. So I can find my a, b, and c. A squared is 36, which means a is 6. B is 4. Since b squared is 16, I take the square root of it to get b. So using my same equation that I did in example 1, I want to find my c value. So 36 minus 16, which is 20. So I know c is the square root of 20. So my original vertices, since it is horizontal, my vertices are written as the number, comma, 0, and my vertices are still based on my a. So I'm going to do positive 6, comma, 0 and negative 6, comma, 0. My foci are based on my c values, so I have the square root of 20 and the negative square root of 20. And my minor axis length is still 2 times b. Since my b was 4, 2 times 4 is 8. So now I'm going to find my new center, my new vertices, and my new foci. So my new center is at 3, comma, 0, positive 3 here, and then there's nothing by the y, so that's where the 0 comes from. To find my new stuff, I take my original, I add my new center to it, and then I can get my new vertices and my new foci. So 6 plus 3 is 9, 0 plus 0 is 0. Negative 6 plus 3 is negative 3. So I have my 2 new vertices. For my foci, I am going to use my calculator again. So the square root of 20 plus 3 looks like I'm going to round it to 7.5, comma, 0. It ended up being 7.47. And then I'm going to do negative square root of 20 plus 3, which is negative 1.5, comma, 0. Again, I rounded that one. I ended up getting negative 1.47. So for this graph, since I know it was shifted right, I'm going to scoot my graph over a little bit. Oh, you can't even see that. I apologize. So I extended it on the right side because I knew it got shifted to the right. So I'm going to go ahead and I notice it goes up to 9. So I'm going to go to about 10. So this is 10. And then everything else I'm just going to do like 5. So I'm going to start with my new center, so 3, 0. So 3, 0 is here. That's my center. My vertices are at 9, 0, so this is 9. Make sure I counted that right. And then another one at -3, 0. I realize as I'm doing this, it looks like these are a little bit closer together than these tick marks. It's a sketch, it's not perfect. I have my foci, so 7.5. So this is one of them. And then -1.5, 0. And then to figure out how wide my minor axis length is 8, so starting at the center, I'm not going to go left and right because those are where my vertices are. I always want to go opposite. So I'm going to go up and down this time. I want to go 4 in either direction to get a total length of 8. So 4 up and 4 down. And we can make our ellipse. Not the greatest, but it's okay. So we did 2 examples on the front with sketching a graph. So we're going to flip over to the next page. On the next page, we're looking at if we're given information or given a picture, we're going to write an equation that matches or that goes with those. So we always want to figure out where our center is so we can figure out how it's been shifted so we can work backwards to find our original pieces of information. So looking at example 3, it says find an equation for a conic whose graph is shown to the right. I love that there's a graph here because it makes it a lot easier, and I'll show you why. Since I have the dots for my vertices and co-vertices, I'm going to draw in my major and minor axis. So I can tell just by looking at this that it's vertical because it is longer up and down. Horizontal would be longer side to side. So this is vertical, which means my major axis is also vertical. Again, I don't have a good ruler, so I'm going to use my notepad, and I am going to, let's do it this way, connect my vertices and co-vertices so I can have my major axis and my minor axis. The reason I did that is because wherever they intersect, so this point, this is my center. And I need to know the center because that would be my h and my k that I can then plug into my formula. So over here, I'm going to write my center is at -1, 2. So that means that h is -1 and k is 2. Your center is always at hk. And then I also know my major axis and my minor axis. So my major axis is this vertical one, and I'm going to count how long it is. So if it's up here, I have 1, 2, 3, 4, 5, 6. So it has a length of 6. My minor axis has a length of 4. And this is important because I know my major axis is 2a. So if I know 6 is equal to 2a, that means that a equals 3. I know my minor axis is equal to 2b, so that means my b has to be 2, because I just divide both sides by 2, divide both sides by 2. And I just want to show real quick how I know this. So on our formula sheet, our major axis, when we have a vertical ellipse, is also vertical with a length of 2a. Our minor axis is horizontal with a length of 2b. So that information is on our formula sheet, and that's what I'm using to get these. Now that I have my h and my k, I have my a and my b, I can plug what I know into my template. And specifically for my vertical ellipse, I am going to be using this one. So I'm going to write the template down first. Where my larger denominator, which is a squared, is under my y. So I'm going to plug in what I know. I have x minus h, so I'm subtracting a negative 1. Well, I know if I subtract a negative, it turns into a positive, so I have x plus 1, quantity squared, all over b squared, so 2 squared, which is 4. Then I have a plus sign. I have y minus k. My k is 2, so y minus 2 squared, all over a squared. Well, since a was 3, 3 squared is 9. And this is my equation. So significantly less time to do it when we have a picture here. All right, we have one more example we're going to look at, which is example 4. So we want to write an equation that satisfies the properties with the foci that is given and the vertices that are given. So the first thing that I want to do is I want to find the midpoint of my vertices, and that is because that will give me my center. So to do that, I need to basically find the average of my x values and the average of my y values. So I'm going to do my x values first, negative 12 plus 8 divided by 2. This is x equals. So that would give me negative 4 over 2, which is negative 2. So I know that the x value of my center is negative 2. I want to find the average of my y values. Well, since they're both 2, the average is still going to be 2. So the y value would be 2. So that tells me my center is at negative 2, comma 2. I need this because now I'm going to work backwards, and I'm going to take my vertices. I'm going to subtract my center from it because we're going backwards. We're not adding, we're subtracting to find my original vertices. Same thing with my foci. I take these, I subtract my center from it to find my original foci. So I'm just going to make a note on the side here. We're going to do new vertices minus the new center is going to equal our original vertices. So I'm going to do negative 12, comma 2, and I'm going to subtract my center, which is negative 2, comma 2. I only subtract the x's, and then I only subtract the y's. So negative 12 minus a negative 2 is going to be a negative 10, and then 2 minus 2 is 0. So that's one of my original vertices. My other vertice is 8, 2, so I got to do that one as well. So 8, 2 minus our new center is going to equal our original vertices. So for my x's, I have 8 minus a negative 2, which is a positive 10, and then 2 minus 2, which is 0. So we have our original vertices. Now we're going to find our original foci. So our new foci, and we're going to subtract our new center to get our original foci. So very similar to what we did above. I'm going to do negative 10, 2 first, and then I'll do this one. So I have negative 10, 2 minus my new center, so still negative 2, 2. Negative 10 minus a negative 2 is going to be a negative 8. 2 minus 2 is 0. For my other foci, I have 6, 2. And I'm going to subtract my center from it. So 6 minus a negative 2 would be positive 8. 2 minus 2 is 0. If you're not sure about subtracting negatives, just double check it in your calculator. So as of right now, I have a lot of information, and I'm going to label it. So I have my h, oops, it was working, and my k. Since my original vertices were at negative 10, 0 and 10, 0, that means my a value has to be 10. Since my foci are at negative 8, 0 and 8, 0, my foci is based on my c. So my c is 8. And again, I'm just using my formula sheet. So on here, I know if I look at my vertices, it's based on my a. And if I look at my foci, it's based on my c. The other thing I want to notice is, let me go on this side, I'm so sorry. If they're written as the number, 0, I'm going to look at my formula sheet to see if it's a horizontal or a vertical ellipse. So for my vertices, I have a, 0 or 0, a. Well, since they're written like this, I know it has to be horizontal. So I'm looking at this whole side. So I also know that it is horizontal. So the template that I need, we're not done because I still need to figure out another piece of information. I'm going to go up here. We have x minus h squared over a squared plus y minus k squared over b squared equals 1. Well, I have my h and I have my k. I have my a, but I don't have my b, so that's what we need to find. Since I have a and c, I can do that. So down here, I'm going to do c squared equals a squared minus b squared. I need to plug in 8 for c. So I want to do 8 squared, which is 64, equals a squared, which is 100, minus b squared. So I'm going to solve that for my b squared. So I end up getting, I'm going to scoot it up a little bit so you can see, 36 equals b squared. I did skip a couple steps. I end up getting a negative 36 equals a negative b squared, so I divide both sides by negative 1. So I get 36 for b squared. Now I have enough to write my final equation. So I have x minus my h, which is negative 2. So minus and negative turns into a plus, all over a squared. Well, a is 10, so a squared would be 100. Then I have y minus k, which is 2, all over b squared. B squared is 36. I also want to point out for this one, it's written as b squared. This was only written as a, so I did have to square that to get 100. I didn't have to square this because it was already squared. And then it equals 1. And this is my equation for my shifted ellipse.